Welcome to this video where we'll be exploring the top 10 data scientist interview questions and their responses, designed to help you sharpen your skills. Let's jump in and get you well prepared for your next data science interview.
Question 1. Explain what a p-value is.
Definition: a p-value is a statistical measure used to assess the evidence against a null hypothesis. Purpose: it helps data scientists determine if observed results are likely due to chance or if there's a meaningful effect. Significance level: a lower p-value, usually below 0.05, indicates stronger evidence against the null hypothesis. Decision rule: data scientists use the p-value to decide whether to reject the null hypothesis in favor of an alternative hypothesis. Example: let's say you're in charge of predicting sales for an online store. You've fine-tuned your forecasting model to improve accuracy. Using p-values is like checking if the increase in predicted sales is legit or if it's just random chance. If the p-value is low, like less than 0.05, it's like hitting the jackpot. It suggests that your model adjustments are likely the reason for the more accurate sales predictions.
Question 2. What is the difference between supervised and unsupervised learning?
Supervised learning. In supervised learning, you're like a teacher guiding a model through a labeled dataset. It's like showing a student examples of math problems along with their answers. The model learns to map inputs, the problems, to outputs, the answers, and gets better at solving similar problems it hasn't seen before. Example: think of training a model to recognize cats and dogs. You show it pictures labeled as either cat or a dog, and the model learns the patterns to make predictions on new, unseen pictures. Unsupervised learning. It's like giving the model a puzzle without telling it what the picture should look like. The algorithm explores the data on its own, finding patterns or grouping similar things together without having predefined labels. Example: consider clustering customer data based on their shopping behavior. The algorithm groups customers with similar buying patterns without being told explicitly who belongs to which group.
Question 3. How do you handle missing data in a dataset?
Missing data can be handled through techniques like imputation, where missing values are filled in based on statistical measures such as mean, median, or regression imputation. Alternatively, data can be removed if missing values are too extensive, or advanced methods like predictive modeling can be employed.
Explain the concept of regularization.
Regularization is like a coach guiding a model to find the right balance in training. It's crucial when you want to prevent a model from becoming too fixated on the training data, ensuring it doesn't memorize every detail but generalizes well to new, unseen data. Types of regularization. L1 regularization, lasso. L1 regularization is like having a coach that encourages minimalism in workouts. It adds a penalty based on the absolute values of the coefficients, prompting some weights to become exactly zero. This is helpful in feature selection, keeping only the most impactful features, just like focusing on the most essential exercises in a workout routine. L2 regularization, ridge. L2 regularization is similar to a coach encouraging a well-rounded workout routine. It adds a penalty based on the squared values of the coefficients, discouraging excessively large weights. This prevents any single feature from dominating the model, promoting balance, much like avoiding overemphasis on one exercise in a workout routine.
What is the course of dimensionality?
The curse of dimensionality is like a challenge in data science that pops up when dealing with lots of features. As the number of features, like age, income, preferences, goes up, it gets trickier to find meaningful patterns in the data.
Question 6. What is the bias-variance trade-off in a machine learning?
The bias-variance trade-off in machine learning is like finding the ideal middle ground for your model. Too much bias can oversimplify, missing important details, while too much variance can make it overly sensitive to the training data, struggling with new information. The goal is to strike a balance, creating a model that is neither too simple nor too complex, but just right for making accurate predictions on unseen data.
What are the challenges in data cleaning?
The challenges in data cleaning typically revolve around managing and preparing data for analysis. Some common challenges include dealing with missing values, handling inconsistent formatting, identifying and addressing outliers, managing duplicate entries, and ensuring data accuracy.
How do you select feature for machine learning model?
Selecting features for a machine learning model involves finding the most impactful details. It's like identifying the key ingredients in a recipe that truly shape the flavor. First, focus on features with a strong connection to what you're predicting, emphasizing those that directly influence the outcome. Use methods that highlight the most crucial features, similar to picking ingredients that make the biggest difference in creating an accurate prediction. Employ smart techniques to simplify without losing essential information, making the process more manageable. Finally, choose features that consistently show patterns across different tests, ensuring reliability in predicting outcomes, much like selecting ingredients that consistently contribute to a delicious dish.
Question 9. What is the difference between overfitting and underfitting?
Overfitting occurs when a model learns the training data too well, capturing noise and resulting in poor performance on new data. Underfitting, on the other hand, happens when a model is too simplistic and fails to capture the underlying patterns in the data. Striking the right balance is essential for optimal model performance.
The last question of this video is, what is the data science life cycle? Before jumping to the reply, please subscribe my channel. The data science life cycle is fascinating journey that begins by defining the problem, collaborating closely with a stakeholder, and then dive into collecting data, cleaning data, find the patterns. Feature engineering shape variables for modeling, leading to creation and evaluation of machine learning model is the next step. Once our model validate, then we can deploy into real world applications, continue to monitoring and maintaining to ensure that all goes well. And this process is like a cycle with a feedback and iteration would be better and better. Uh, at the end, we should ensure that the journey stays dynamic and relevant. Thanks for watching this video.